Scientific notation is a way of taking big numbers, and by big numbers I mean numbers that take a lot of space to write down. So they could be actually very small numbers as well. But taking numbers that take up a lot of space and then writing them in a way that doesn't require so much space. So for example, here we have 960 billion 100 million. Which can be written just as 9.601 times 10 to the power of 11. So we're going to understand how this is done by looking at some exponent rules first to understand how we get this 10 to the exponent 11. So just as a reminder, we have 10 to the power of 1 is just 10, 10 to the power of 2 is 100, right? And 10 to the power of any number is equal to just 1 followed by that number of zeros. So in this case, I believe I have 9 zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So this is 1 billion, and that can be represented very easily by just saying 10 to the power of 9. So the idea behind scientific notation is that we can shorten numbers by adding a multiplier of 10 to the power of whatever. Okay, and another reminder, to multiply by 10, if you have some decimal number like 5.23, multiplying by 10 is just a simple moving the decimal one spot. So in this case, the answer would end up being 52.3. Okay, so now if I were to say multiply by 100, then I would end up moving the decimal one more spot. So I'd erase this one and put the decimal here. So it would end up being 523, right? So where the decimal is placed is a function of what power of 10 we're multiplying by. All right, and so that's a brief explanation of the exponent rules that you will need for understanding scientific notation.